So, you want to be a game developer? Maybe you want to take your players on adventures in deep and dark dungeons, pixel art towns, or nightmare-filled forests. It's easier if you know the modern, state-of-the-art game development tools that make the whole process from placing the first game object to exporting the final build of your game so much easier. Let's draw a game world for players to discover and explore using tile maps. Let's get creative and design our own unique pixel art player characters, animate them, make them move, add cinematic camera, implement physics and collisions, and so on. Today, we will use a game engine to create a top-down pixel art RPG completely from scratch, and we will learn how to export the game as a native Windows and Mac application. We might also do another build and publish our project as a web game using WebGL technology. Unity is an intuitive, beginner-friendly, and widely used game engine. You can build anything from a small demo to a big, ambitious, genre-defining, multi-platform game. If you check how many job offers are there for Unity developers, you realize it's a very viable career choice. Come try it with me for this project and make up your own opinion. By the end of this class, you will have a playable version of your game as a desktop application for Windows and Mac computers, and you will have another build of the same project as a HTML web game. You can send a link to your friends and they can play test it in their browsers and give you some feedback. Click the like if you are ready to discover how easy it is to make games using a game engine. This class is for beginners. The first quick step, let's install Unity and create a free account. Unity is completely free to use. I just Google something like download Unity and I go to the official website. It downloads Unity Hub. It's a separate application to access everything in Unity ecosystem. Now you can just click it to install. I already have an account. At some point you will be asked to register an account. Choose the free plan. Personal plan is free for individuals and small organizations. I installed Unity Hub and I open it. Here in the Installs tab, we can have multiple versions of Unity Editor, which is the actual game engine we will be using to create games. In 2024, we use long-term support version 2022.3. If you watch this in the future, I recommend installing the latest LTS version, long-term support. Everything will still be compatible, maybe some menus will look slightly different in the future. At some point in this process, you will be asked to log in with your free Unity account. You can see I'm already logged in. I go to My Projects tab and I click New Project. Here is where you first realize the power of a game engine. You can make 2D games, 3D games, mobile games. All is quick, easy and intuitive. Let me show you. Unity exports to every platform. While you are here, you might want to check what learning projects they currently offer. You can just open this 2D platformer microgame and follow the tutorial steps. It's fun. For this 2D pixel art RPG, we will use Unity's 2D Universal Render pipeline. Project name is Underground Explorer. I choose a folder on my computer where I want to create my project. Now we can click Create Project. When you first create a project, it can take a few minutes to set up. Unity is a visual scripting tool, which means that it has a lot of graphic interfaces where we can organize the game logic, and it automatically writes the code for us behind the scenes. We will learn all about that, and we will also write a few simple scripts ourselves. This is the default Unity layout. Here in the hierarchy panel, we will see all our game objects. So far, we only have objects for camera and light, but we will add player and other game objects here as well. Here we can see the entire game scene. This rectangle is what the game camera sees, so any objects outside will not be visible in-game. I can check the game view on this tab here. If I right-click here and select 2D object, tile map rectangular, it will create a game grid and this new tile map game object inside. I will rename it and call it background. Down here we have project folders. This is where we put the art assets and other things. And this panel is for Inspector. As you click different game objects here, Inspector will show you details about each game object and about its components. For example, now I selected my new background tile map, and here I can see it has a transform component, tile map component, and tilemap renderer component. We can add more built-in components that Unity offers to, for example, animate it or to apply collision detection. And we can also add our custom script as a component here and write our own logic. We will learn all of that today. It's very easy and intuitive. If I select different game objects here, you can see that the Inspector tab changes to give us details about the currently selected one. So, to make our game, we need to import some art assets here. We create our game objects here, and we add some built-in and some custom components on these game objects here. This is where we see the game we are building. Well done, now you understand Unity. Let's do it. I go to my Assets folder, I right-click here, Create Folder. I call it Art. All the links and resources you will need today are in the description down below, right next to the like button, just in case you want to make me happy and click it. Today we will use itch.io for the art assets. I select Game Assets. We want to filter top-down. It's a tutorial, so I want everyone to follow, so we will use free art assets. You can filter by price here, but if you find your favorite artist, buying their art is the best way to support them. One of the artists I recommend is this one. Their art has so many small details and care put into it. You will see in a minute. I like that because we put a lot of care and we focus on small details in our games as well, so it's a perfect match. Choosing the right art for your game is an important decision. I really want to use some of these for a pixel art platformer, but today we are doing a top-down RPG, so we can use any of these tile sets. I will use this one called RPG Worlds Caves. It's free. You can click download now, you can support the artist and pay some money, or you can just click no thanks, just take me to the downloads, and you can get this entire asset pack for free. Here I click download and I choose where on my local computer I want to save the zip file. I extract the files. There are even some animated tiles here. We also have Photoshop source files. You can read the license. For now I will use these two images. In Unity, I go to Assets, Art, I right-click, Create, Folder. I will call it World. I drag these two images inside Unity. When I click this arrow, you can see the image is just a single tile. Spritesheet is an image made out of multiple frames. With this file selected and having Inspector window open here, I see all kinds of details about the image file. In sprite mode, I select multiple. This image contains multiple sprite frames. I go back here just to check some details. I can see that this particular tile set is 32 x 32 pixels. Single frame in this tile map is 32 x 32, a very common size for pixel art. Also, you can check the license here. We can edit and modify this asset for commercial purposes. We can use this asset in our game, and we can publish and sell that game if we want to. Perfect. Back in Unity, with this image selected, inside Inspector tab, I set pixels per unit to 32. We want to make sure that pixel art stays sharp. In Unity, we do that by setting filter mode to point, no filter, and we set compression to none here. Now we can click Apply. Because we selected multiple here, we are telling Unity that this image contains multiple sprite frames. I click Sprite Editor here. I can zoom in using my mouse scroll wheel. If I press and hold the scroll wheel or the right button on my mouse, I can drag the image around. I can choose any texture I want. I will choose these two. They are compatible and I can see they were designed to seamlessly blend into each other. We want to slice this large image into individual frames, into tiles. I select Slice. Type will be grid by cell size. I remember that this particular tile set was 32 x 32 pixels. Let's move here. Yes, that's right. I click Slice here, and I click Apply. You can see that Unity created individual tiles, and it discarded the tiles that had no pixel data in them. This is a large asset. It might take Unity some time. It set up coordinates and auto-generated name for each tile. We can keep it like this, but I want to show you something a bit later, so I will rename a few of these tiles. It will make them easier to find because there are so many here. I want to create a paintbrush that will randomly choose one of these 9 tiles. So as I paint the ground, they are organized randomly. We don't want to see any repeating patterns. It is not necessary to rename them, it just makes our life a bit easier in the next step. So this is ground underscore 01, ground 02, 03, 04, 05, 06, 07, ground 08, and ground underscore 09. I click apply again to save the changes I made. I let Unity process this. I close the sprite editor. If you click this small arrow now, you can see that this image is now made up from many individual tiles. The other image was not sliced yet, so it's still just one big piece. Also here I can easily identify the 9 ground tiles. This asterisk here means we have some unsaved changes, so I press Ctrl+S to save. Now I want to use the tiles we sliced as a paintbrush to draw the game world. I go to Window, 2D Tile Palette. I can move it around and attach this panel anywhere I want. I will put it up here next to the inspector. I expand this and I pull this down to give us more space. Here we can see it's given us instructions on what to do next. So I will create a new palette in the drop-down above. Create new palette. I name it, for example, World, and I click Create. Inside the project structure, inside Assets, Art, World, I right-click to create a new folder. I name it Tiles. I enter the folder and I click Select Folder here. We created tile palette called World. Now you can see it's telling us to drag assets here. Down here I'm inside Assets, Art, World, and here I have my tile palette window open. I take my sliced tile map image and I drag it here. Now again I go inside Assets, Art, World, Tiles, and I select Folder. I wait until Unity processes the art assets and creates my tile palette. Again, I can use mouse wheel to zoom in and out, and if you hold the mouse wheel or right mouse button down, you can drag the tile map around. In my sample scene, I select background game object, which we know is a 2D rectangular tile map. I can zoom in and out by using mouse wheel. Game view, so far we have nothing here. I have my tile palette window open here and I'm looking at our custom tile palette we called World. If I highlight a block of tiles like this, Unity will automatically select a brush tool. Brush allows us to take big blocks of tiles and place them on the target tile map. If I select my tile map here, it will be highlighted like this, but more importantly, I need to have my background tile map selected here to specify where we want to draw. It will become especially important later when we have multiple tile maps layered on top of each other. I can also select individual tiles. We can check our game view, and we placed a sunny cave wall up here. This white rectangle is what the game camera can see. With brush tool still selected, I can get this tile block, the cave entrance, and I create a home for the player. We have other tools here that we can use to draw the tiles. This one is called Filled Box. If I select this one black tile, I click and drag, it fills the box area with that selected tile. The third important one here is called Erase with Active Brush, which means that we turn our brush area into an eraser. I'm just deleting one tile at a time, but I can also create a big selection here. I go from brush back to eraser, and as you can see, the size of the eraser is the same as the selection we made here. This is very useful. So standard brush, box fill brush, and eraser. You can do so much with just these 3 tools. Let me show you. The cave walls will actually not be on the background layer. We will use those walls in the collision layer later. Background will be some ground textures the player can walk on. This tile map has multiple different texture options. If you hold down mouse wheel or right mouse button while your cursor is over the tile map, the cursor will turn into a hand and we can drag and move it around. These two blocks are compatible with each other and they can be arranged into any seamless pattern. If you never used a tile map before, someone put a lot of work and made sure that even though it looks like we only have a patch of grass surrounded by dirt and a patch of dirt surrounded by grass, or maybe this is not grass, it might be some cave fungus growth. The tiles are designed to blend in seamlessly and to create any kind of continuous 2D shape we need. We can use these two blocks of tiles to create a winding road of dirt through the grass if we want, for example. Let me demonstrate and let's create some interesting ground texture to our dark, damp cave. If I select a block of tiles and I have a brush tool active up here, it allows me to place the entire block at once. I place it here, then I select just a part of that block. I zoom in and I can extend it. Side piece here, 3 middle tiles here, and this side piece here. We are extending the fungus patch to a taller rectangular shape. If I zoom in, I see that this tile connects seamlessly to this tile, but not to the one I have here. We can actually mix and match, so to fix this to be seamless, I can select this entire block here and use that as a side of this block here. I can also select this big block of dirt surrounded by fungus growth and place it here. We have these diagonal pieces we can use to connect corners. I place this one here and we will go to the right to connect with the other block like this. Another diagonal connection piece. I will actually continue my shape through this. I select this block of 9 dirt tiles and I print them all around here. I select the grass tiles and I will roughly outline where I want the grass patch to be. I'm making it very irregular on purpose so that you can see how it can be organized seamlessly into any shape you might want. This block of 6 here. Okay, and now I have to do the edges. Some bottom tiles here, diagonal connection piece, a bottom piece. Notice that I can use these as the bottom pieces or I can also use these. They are the same basically. Now I want to go up. If you want to see if it connects seamlessly or not, you can go into game view. It's more obvious here. I can see a few issues, easy to fix. I don't always have to use diagonal connectors in these corners. I can also do a sharp turn like this and it will still work well. I continue around the shape. These don't connect. These do. I keep going up here. Maybe I put that more to the left. Top piece, left side. And let's make it even more irregular. Yes, this still works. You don't have to do exactly what I'm doing here. You can make yours much simpler or much more complicated. It's up to you. I'm just building something, trying to show you how the tile map works. You get a better feel for this if you play with it. This is a bit more advanced tile map. It allows us to create really irregular shapes. It actually connects in more ways than you might think. It's so good. This is some top quality pixel art. In game view, you can see the shape is starting to come together nicely. If you follow the edges, you will be able to spot any problems. Before we polish this, let me show you one thing. If you look at these 9 grass tiles and these 9 dirt tiles, they are all slightly different. Let's say I want to cover a larger area with just dirt tiles. If I just take 9 of them and I start printing that shape of 3 times 3 tiles, one next to another, we will get a very obvious repeating pattern. What if I want to randomize them and make the area look a bit more natural? I can come here and create my own custom random brush. In number of tiles I put 9. This will give me 9 tile slots. I click here. And if you remember, we renamed 9 dirt tiles as ground 01, 209. This makes them so much easier to find here. I can also search by name if they are not up top. I select ground 02 for the second slot. We know that's this one. Ground 3, ground 4, ground 5, ground 6, ground 7, ground 8, and ground 9. With random brush selected here, and standard brush tool selected here, I can now paint my dirt tiles and they will be randomized. So I fill the gaps all around in the area that game camera can view. I also do the left edge, maybe 2 tiles thick for now, 2 rows of randomized dirt tiles on the bottom, 2 rows on the right side, and 2 rows up top. Awesome. I select a grass tile and I go back to default brush. I made sure that the brush tool is selected here. I patch this a bit and I check if it all connects seamlessly. I can see some issues here on the left. Back to scene view and I take this left edge block. I patch this bit and this area. I inspect my tile palette. If I go to the left, we have some decorative pieces, grass and stones. I just need to make sure I select the right ones. I'm not that color sensitive. To me, these colors look very similar, but they are a slightly different shade. These ones match, so back to scene view. Background tile map here. We are drawing on the background layer here. With paintbrush selected, I pick some of these decorative pieces and I place them randomly over the grass patch. Game view, okay, good. Back to scene view and I place some stones, again completely randomly. Here, here, another one here. Let's see, maybe some more here. We learned how to use tile maps to create random, seamlessly connecting shapes. We will come back to this tile palette later to expand the ground to a much larger area and to create some caves and maybe even underground lakes. First, let's add a player into our game scene. As we work in Unity, maybe you moved or resized some of your panels or some of your windows disappeared. I will work in the default layout in this class so that everyone sees the same thing. If you are a more advanced Unity user, you know where things are. If you are a beginner, you can go to Window, Layout, Default, so that we all see the same thing and we are ready for the next lesson. One more thing here, if you select a game object, let's say I'm zoomed in, and if I press F, Unity will focus that object. I can also press play here. So far there is nothing interactive in our game, so it will be static. One important thing to remember, always exit play mode before making any changes. Some changes you make will not save while in the play mode. I know we are in play mode because I can see this object here and play button is highlighted. Click the like if you got any value so far and let me know in the comments if you used tile maps before or if this is your first time. Now let's get to the fun part. It's time I ask each one of you to create your own unique player character. I will use this awesome tool to create and customize our player. It will export a spreadsheet with a unique character for us and we will use that in-game. This pixel art character generator allows us to create an insane variety of creatures and game characters. Let me show you some of the options we have here. I will link the website in the description down below, or you can see the URL here. If you are watching this in the future and for some reason the website is not available anymore, I will leave some alternative compatible art assets you can download and continue with this class. We can click the animation preview here to make it larger or smaller. And we can also click the sprite sheet to enlarge it. We can give the game character a different body type. We can preview available animations in this drop-down. Spellcast animation. We will use walk animation for sure. We can give our character a shadow. Here I noticed one thing. Shadow is only applied to the standard animations. When we go a bit further down to special animations, shadow doesn't work on these. In this class, I want to implement walk and also idle animations, which looks like this. You can see it has no shadow even though I added that for some reason. We have other cool features here. Look at the wings. I can give my character platinum feathered wings, or maybe dark brown, black. We have body color option here, but some choices later recolor the body automatically, so I will not select any body color. Rose. White wings. My favorite choices are here, heads. You can do basic humans up here, but I'm more interested in some of the fantasy and sci-fi choices they offer. Notice that if I choose a head, it recolors the body to match it. It works for human bodies as well as for the creatures. I also like these bat wings. Gold, violet, light brown. This is such a cool pixel art tool. Great for prototyping, at least for sure. Black sheep, white sheep. What does Minotaur look like? This would work well to use as enemies in a tower defense game. I'm getting so many ideas right now. If I go down to advanced animation, you can see that the Minotaur texture works well, but we lost shadow and we lost wings down here. We can walk, but when I do idle, we lose shadow and wings. It's not a problem at all, but we have to think this through. For this class, if you want animated idle state, we have to remove wings. If you want wings, you can keep them. I will show you how to create a static single frame idle from the first frame of walk-in animation. It will look good, just not animated. If you are okay with that, you can go crazy with all the customization options this tool offers. Just check if they work for walk-in animation. If you want animated idle, let's make our character a bit more simple. I remove the wings up here. The second part of URL actually lists the unique options we choose for our character. And this tool has what I would consider a bug. If you choose wings and then choose none, it will say wings none here. That's not needed, it should just remove that part. I will show you how to easily create our own shadow in Unity, so I select no shadow. If I delete shadow none and wings none from the URL, character stays the same. I will link a few different characters using this URL system below, and if you share some of your unique characters with me and I like them, I might include those as well, with your name in the video description. Show me what you can come up with. If you want to comment, don't share the full URL. YouTube comment section usually marks links as spam. It's better to share only the second part of the URL, and I can easily add the first part on my end. That way, your comment is safe and spam filter will ignore it. If I keep my character a bit more simple, we can use even the advanced animations like run. These animations up top will work with wings. It's good to test it before you export your final creation. I can create Master Splinter. I think Lizard Tail would work well in this case. Yeah, this is nice. I remove the tail. We have some monsters here. Skeleton, zombie, jack-o'-lantern, vampire, Frankenstein. Okay, we have to make a Halloween tower defense with this at some point. I want to create some cave-living fantasy creature. Orc, goblin or troll. Let's see. Black, or I can create thrall, bright green orc. This is giving me some Warcraft vibes. My orc will live in a cave. It will be pale green, because there isn't much sun. I'm going with this. Feel free to create your own character if you want. Just make sure it has a working walk animation in the drop down here. If it also has an animated idle, I will show you how to implement that in Unity. Otherwise, we will use the first frame from walk animation cycle, which was also specifically adjusted to be used as a stand-in idle frame. If you inspect the sprite sheet closely, you will see the first frame of walk has legs more spread out. When you are ready, right-click your sprite sheet and save image as. If you want to use the same exact character I just created, I will link it in the description below. In project folders inside Unity, I go to Assets, Art, I right-click and choose Create and Folder. New folder will be called Player. I go inside and I drag and drop the player sprite sheet we just created. If I click this arrow, we can see that there is only one sprite frame. So with the player sprite sheet selected, I go to Inspector panel. I know that the website we used exports sprite sheets that are 64 × 64 pixels. Pixels per unit, 64. This image is made out of multiple sprite frames. Filter mode is point no filter, because this is pixel art and we want to make sure it stays sharp. Also for that reason we set compression to none. I click apply. I open sprite editor by clicking here. And if I zoom in using mouse wheel, you can see that my pixel art orc is still blurry. It's because this image is quite large. There are so many frames. The image itself is 832 pixels wide and 2944 pixels tall. I close this. I have to allow the sprite sheet to reach its full max size. I know that in this case 4096 will be enough. I click apply. I zoom in. This looks good. If you are using even larger image, you might have to increase it to 8192. I apply, sprite editor, zoom in. Well, this is as sharp as it gets. Perfect. While I'm in sprite editor, I will slice this into individual frames. Slice, type grid by cell size. 64 times 64 is the right value for this particular sprite sheet. I click slice and I click apply. You can see that Unity discarded empty frames with no pixel data, and it auto-generated names and coordinates for each frame in the sprite sheet. You can also rename frames for individual animations you will need here, because it might be easier to see where each animation starts and ends in this view. I'm quite familiar with how this sprite sheet is put together, so I will leave it like this. We can close Sprite Editor. Inside Assets, Art, Player, we can click this small arrow next to the player sprite sheet, and we can see it is now sliced into individual frames. In case of my sprite sheet, player 78 is the first frame on the walk-in row. We want to start by walk down, so the player faces the camera when the game first loads. This sprite sheet is designed in a way where the first frame of walk is a non-animated idle frame. You can notice the legs are a bit more spread out. The character is in a resting position, just for this one frame. Then we have walking down sequence here. I left-click this frame and I drag it into the hierarchy. Unity will turn it into a game object. I save my changes. Ctrl S. If I zoom in, I notice that player is highlighted because it's selected here, but it's behind the background. I select Move tool, and then we have this little blue square that I can use to grab and drag the character around. We need to learn how to control layers in Unity. It's easy. I go up here to Layers and Edit Layers. This will open tags and layers in my Inspector tab. For now, we care only about sorting layers. These layers determine in which order are game objects drawn in the game scene. What is drawn first and what is drawn on top of that, basically. I click the plus button, Add to the list, 3 times to add 3 more sorting layers. I name them Background. On top of that will be Player. And on top of all of that will be Foreground. Now we can assign each game object a different sorting layer. I click on Background tile map here, and inside Inspector window I go to Additional Settings, Sorting Layer, and I select Background. I select Player Object, Inspector tab, Sorting Layer, Player. Now Player finally appears. If I go back to Layers, Edit Layers, I'm inside Sorting Layers. If I drag Background to the front, Player is hidden behind it, so I put it to the back. I hope this makes sense. I select the player object and I will rename it to Player here. Looking at this, I would probably like the player to be larger in relation to the ground texture. With player object still selected, Inspector tab and Transform component. Here we have horizontal and vertical scale. I could double the player size. I go back to 1:1 scale, and another way to do this would be to go to Art, Player, and with player sprite sheet image selected, inside Inspector tab I can change pixels per unit. I select half of 64, which is 32, and I click Apply. Let's see. Yeah, I think I prefer this size. Unity is a visual scripting tool. It means that we can do so many things using its graphic interfaces, and it generates the code for our game automatically behind the scenes. I want to show you how we can write our own small and very simple custom script. This is beginner friendly, don't worry. If this is the first time you are using Unity, you should associate your preferred code editor with Unity. I go to Edit Preferences, and here I go to External Tools. Here in External Script Editor dropdown, I select what code editor I want to use. You can see I'm using Visual Studio Code. I think it works with many different code editors. I haven't tested all of them, so you can try and see if your preferred code editor can be selected here. Basically, all this does is when I double-click a custom script somewhere inside Unity, it opens it in the code editor we chose. In my assets, I right-click and select Create Folder. I will call it Scripts. I open the folder, right-click, Create C# script. Don't worry if you never used C# before, this is easy, I promise. I name the script player controller. I select player object. I'm inside Inspector tab here. You can see we have transform component to position the player somewhere in the game world. And we also have sprite renderer component to draw the player image. I go down here and I click add component and I type player controller. We created a new script inside assets scripts. We selected our player object and we added that player controller script as a component on the player object. Now I can double click the script here, or I can also double click on it here and it will open in my preferred code editor that we just set up. For me, it's Visual Studio Code. You can see that Unity auto-generated some code for us. This is C#. Don't worry if you have never worked with C# before. If you know what a function, variable, and class is in any programming language, you know enough to fully understand this code we are about to write. Unity created a public class called player controller. That class extends a parent called monoBehavior. MonoBehavior is something Unity uses to allow us to attach our custom scripts to game objects. If you remember, we just added this player controller script as a component to our player object. MonoBehavior also provides us with hooks into important events such as start and update. Don't worry about it too much at this point. By the end of this class, you will understand everything. I want the player to respond to controls. Back in Unity, I think I need to cover this now. In Unity, there are multiple ways to make objects move. Let's keep it simple. First, I select my player and I click Add Component and I select Rigid Body 2D. Make sure you select the 2D version, not just Rigid Body. This turned player into a physics object. Look what happens if I press play. Player falls down off screen. It's affected by gravity. I exit the play mode. We can prevent that by changing its body type, but in this case we want to set gravity scale to 0. Now I press play, player doesn't fall anymore. I exit the play mode. There are multiple ways we can make a game object move in Unity. This is important to understand. I can make the player move by changing its transform values in this component, or because by adding rigid body to the player, we turn it into a physics object, we can make it move by manipulating the velocity of its rigid body component. To choose which type of movement is correct for this project, I have to ask myself, is the player going to interact with other objects in the scene using built-in Unity physics system? If so, then we use rigid body movement. I want the player to collide with walls and rocks and maybe to push some game objects around. If I move player using its transform, it will negate the benefits of built-in Unity physics system, and you will see some tutorials that do this. They implement transform movement system on the player, and then they write their own collision detection logic on top of that. It will still work, but in my opinion, I don't think it's necessary, because built-in Unity physics was written by some very smart people, I assume, so I prefer to use that. I don't want to write my own. I want to do this with as little code as possible. Transform movement is cheaper when it comes to performance, so always consider carefully which game object needs physics and which doesn't. Do you want some flying text above the player that shows score, for example? That text just floats around, it doesn't need physics, it's not gonna bounce off anything. So we would use transform movement for that. Do you want your game objects to collide with other game objects? Then use rigid body movement. So as I said, player will collide with walls. We will use rigid body movement here to take advantage of built-in Unity physics system. This allows us to do a lot with very little custom code. Let me show you. I want to use my custom player controller script to manipulate velocity value of rigid body 2D component to make the player move around. First, I will need a way to access this rigid body component from this custom script component. Up here, I can define some class properties, some variables. To declare a variable in C#, you must specify the type and assign it a value. This is a little bit different than, for example, JavaScript. JavaScript is a dynamically typed language. You don't have to state a specific data type when declaring a variable. Type checking in JavaScript occurs at runtime. C#, on the other hand, is statically typed language. You need to declare variable type when you are declaring a variable. So here I'm saying create a custom variable called RB. That variable type is rigid body 2D, And this type will work because we are inside a Unity class. Unity understands that variable type. You will also notice that I'm saying private here. I will show you what exactly that does in a minute. So I'm saying create a private variable called RB. This variable type is rigid body 2D. At this point, I'm just declaring that variable. I'm not giving it a value. You can see my code editor is doing some basic syntax highlight in different colors. If you don't have that, you can go to extensions and install some helper plugins. I'm using C# language support plugin, C# dev kit, and also you can use at least the main Unity plugin. It can be helpful here. It's up to you how you customize your editor. Just make sure you can work with it comfortably, and ideally you want some syntax highlight so you know when you made a typo. Start and update methods come inherited from a monobehavior class. Start method is called just once on the frame when the script is enabled, and it runs before any of the update methods are called for the first time. In here, we put things that we want to happen just once in the beginning. So in here, I want to point this RB variable to rigid body 2D component that also sits on the player object, so that we can manipulate rigid body velocity and move the player around. RB variable from line 7 is equal to built-in getComponent method, and component we are looking for is rigid body 2D. This is the correct syntax. GetComponent method will simply return a component of a matching type. I'm pointing from this component to this component. Is this your first time using C# or have you used it before? Let me know in the comments. You can also click the like button if you found some value so far. I go up here and I will define another variable, and this is where we will see the difference between private and public. I declare a public variable, type is float, floating point number. Variable name is move speed and value is 100. I save changes to my script and I go back to Unity. I let everything compile, and with player game object selected here, you can see that we have a new field here called move speed with a value of 100. We can edit the value from here. This value is visible here because we set it to public in our script. Let's make the player move. With Unity, it's very easy. If I go to Edit, Project Settings, and Input Manager, Unity already has a built-in pre-installed system of controls. We just need to know which keywords we need to access those input values. I open Axis drop-down, and what we care about now is the movement along the horizontal axis, left-right, and vertical axis, up-down. You can see there are many other input events here. If I open Horizontal Movement drop-down, you can see it's already set up with some default values. Negative horizontal movement to the left is the left arrow key, or alternatively letter A on the keyboard. Positive horizontal movement is the right arrow key, or letter D. With this simple basic setup, it will work even if I, for example, plug in an Xbox game controller into my PC, and without any further setup needed, I will be able to control my character like that. It's quite robust out of the box. Notice the name of the field is horizontal here. For vertical, we have down and up arrow keys, and S and W. One thing in Unity that's different from, let's say, HTML canvas is that negative vertical movement is down and positive movement is up. So now we will use these names vertical and horizontal in our custom script, and that's all we need for Unity to connect the input to the player. Very simple. Let me show you. I can double-click my script here or here to open it in my default code editor. I create another private variable of vector2 type called input. This variable will hold X and Y directions of player movement. Vector2 in Unity is a simple structure we use to represent 2D positions and vectors. For example, vector2, 0, -1, like this means that there is no horizontal movement on the X-axis and there is -1 movement on the Y-axis. Negative is down. It's just two values, one for X, the horizontal axis, one for Y, the vertical axis. I'm saying declare a private variable called input that expects X and Y value. Here we have this other method that Unity automatically gives us in the base script file. Update method is called once per frame, and important thing to note here is that it will run at different speed on different devices, depending on how many frames per second is the device capable of. Here I put things that I want to happen over and over as often as possible. These are methods, functions on a class. This void keyword represents the return type of a method. By using void here, I'm saying that this method does not return a value. That's all. So inside update method, which is called once per frame, we set the horizontal component of vector2 input variable to input with capital I dot get axis row, spelled like this. Be careful about capital and lowercase letters. It needs to be exactly as I type it here. And I pass it horizontal with a capital H. Get axis row method for horizontal axis will return the value of virtual axis with no smoothing filtering applied. Horizontal axis is managed by left and right arrow keys or A and D keys, and because there is no smoothing applied, it will always be either -1, 0, or 1. -1 is left when left arrow or A is pressed. 0 means no horizontal input, and +1 means that the right arrow or D is pressed on the keyboard. Input.y is input.getAxisRow vertical. Same applies here. Start method is where we put things we want to happen just once. Update method is where we put things that we want to happen over and over as fast as the device can handle. I will declare another built-in method, void fixed update. In here, we will put anything that relates to game physics. Fixed update also happens over and over, but it's on a fixed time step of 0.02 seconds. Fixed update in Unity happens before Unity does physics calculations, which is important. Update runs on every frame of the game, which will be different from device to device. Some devices can be faster than others. Fixed update runs once for Unity physics calculation step, which happens on a fixed time step of 0.02 seconds, which is 50 FPS, 50 frames per second. Unity calculates physics 50 times per second. If you go to Unity, Edit, Project Settings, Time, you will see the fixed time step value here. So now that we understand this, we know that inside fixed update, we will do things that relate to Unity physics. RB, rigid body component, is a physics object, and we want to move the player around by manipulating its velocity from here. Velocity, again, expects horizontal and vertical component, so it will be equal to vector2. In here, I say input x, the raw input value, which will always be -1, 0, or 1, and we scale that vector by move speed value from line 8. And we multiply that by time.delta time. Delta time is the number of milliseconds that happened between this and the previous update step. We know in this case it's 0.02 milliseconds because we are inside fixed update. We use delta time in this equation to make sure the player moves at the same consistent speed on any device. I have a feeling that we only use delta time in update. There is a possibility that Unity already accounts for delta time automatically inside fixed update without us having to account for that. I will check the latest documentation and I might get back to this. Anyway, the horizontal component of velocity of player rigid body is the input -1 or 0 or 1 times move speed of 100. We might change that value later, times delta time to unify the speed across devices. For the vertical component of vector2, up or down, we use the vertical input times move speed times delta time. I save my changes, I go to Unity, and I let it compile. I press play, and now I can use arrow keys and WSAD keys to move the player around in any direction. Awesome, that was easy, wasn't it? Now you can put C# skills on your CV. I want the player to be able to walk only left, right, up, or down. I want to prevent sideways movement. I exit the play mode. Back in my script, I say if input x has any value other than 0, if the player is currently moving left or right, set vertical input to 0. If the player is moving horizontally, make sure it doesn't move vertically at the same time. This is not the most robust solution, but it will work for now. I save changes. Let's wait for Unity. I play. And now, even when I press 2 input keys at the same time, player cannot move diagonally anymore. Well done. I go to Assets, Art, Player, and I want to give the player a shadow. You can download it in the resources section below. It's just a simple black pixel art ellipse. With shadow image selected here, I go inside Inspector tab and I set pixels per unit to 32. Filter mode, point, no filter, and compression to none to keep the pixel art sharp. I click Apply. I take the shadow image and I drag and drop it here into the scene. Unity will turn it into a game object. Back to scene view. With shadow selected, I use Move tool and I can use this blue square to move the shadow around. It's behind the game background and we already know how to deal with that. Shadow object selected here. Inspector tab, sort in layer will be player. Now we have shadow and player objects on the same sort-in layer. If you want to set order of objects that are on the same sort-in layer, you can use this other field called Order in Layer. Shadow is 0, player will be 1. Player is in front of the shadow on the same sort-in layer. If I play, player moves independently of the shadow. I exit the play mode. I can take the shadow object and I can drag it over the player like this. Now, shadow is a child object to player. Its position will be based on the current position of the player. I set it to 0, 0 here. Move tool. I want it to be somewhere around here. So with shadow still selected, I set transform to 0 and minus 0.86. We made shadow a child object of player. So now if I play, shadow moves with the player. Perfect. We have this massive sprite sheet here. Let's use more frames to actually animate the player. I go to Window, Animation, Animation to open this animation panel. I will probably put it here because I want to see my project panel and my scene panel at the same time while I work with animations. I give myself a bit more space like this. Inside Assets, I right-click, Create, Folder. I call it Animations. With Player Object selected, I go to Animations window and I click Create here. I navigate into Assets and Animations folder and I call it idledown.anim. Save that. We can see that idle down animation here. I go to Art, Player, and this little arrow to expand the frames. If I look at my sprite sheet, idle animation is just a single frame here and the start of walk in row. Or if you created a simple character like me with no wings and your idle animation frames here are usable, you can use these two frames for idle position or this one, which is probably some kind of a combat idle with fists or a weapon ready to fight. Single frame idle would be frame 78 in my case, the beginning of walk down animation. I can drag it here, and if I press play, we can preview it. It looks the same as the default frame, so not much happens here. Use this frame if your character loses some body parts like wings or clothes on the advanced animation rows. If your advanced rows are usable because your character is relatively simple, like mine is, I click the frame and I press delete on my keyboard. I scroll down here to frames 192 and 193 is the standard idle. 194 and 195 is a combat ready idle, I guess. I left click player 192 and while pressing down Ctrl or Shift on my keyboard, I select player 193. With both of these frames selected, I drag and drop them into my idle animation sequence. If I press play, we can see that animation is playing very fast. We slow it down by changing the value in samples here. If you don't see samples, click on these three dots here and select Show Sample Rate. I set it to 4. I play the animation, maybe even slower. How about 2 frames per second? Yes, that's better. OK, I click Idle Down and create new clip in this drop-down. In Assets, Animations, I create Idle Up.anim. If you have a character with wings or more complex parts and you are using a single frame idle, it would be this frame, the start of walk up animation sequence. In my case, I will do the animated idle and I select player 184. I hold Ctrl or Shift down and I click on player 185. With idle up selected here, I drag the frames into the sequence. I set samples to 2. I press play. Yes, this is good. I click here again, create new clip, idle left. For me, it will be frames 188 and 189. I drag them over and I set sample rate to 2 frames per second. Play to check if it works. Nice. I click here one more time, create new clip, idle right. I select frames 196, 197, and I drag them up here. Sample rate 2. If you are using single frame idle, it's these frames: up, left, down, right. Animated idle frames are these: up, left, down, right. You can choose what's better for you depending on what kind of character sprite sheet you generated for your game. Okay, if I go to Assets, Animations, you can see the anim files we created for idle down, left, right, and up. And there is a 5th file called Player. This is animation controller that Unity auto-generated for us. If I double-click it, it will open Animator tab. We used Animation tab to define individual animation sequences, and now we will use Animator tab to define the conditions for transitioning between these individual animation states. You can also open Animator panel by going up here to Window, Animation, Animator. In here you can zoom in and out using a mouse wheel. I can click and drag these individual states, and I can press and hold mouse wheel to drag the whole content around. I left click and select all the states that Unity auto-generated for us from animation sequences. I press delete on my keyboard to delete them. Right click, create state from new blend tree. With this blend tree state selected, I go inside Inspector tab. I call it idle. I double click this to enter idle blend tree. I select this panel and I rename it as well, idle. Blend type will be 2D simple directional. Okay, I have to type the name again, idle. Yes. So now we are inside the Animator window, in base layer and idle. I click this plus button and add motion field. I add one more. I add 2 more, so we have 4 in total. I click here and I select idle down animation we created before. Here I select idle up, 3rd one will be idle left, and the last one I select idle right. While player is in idle state, we will use this blend tree structure to switch between idle down, up, left and right animation sequences based on which direction the character is currently moving. I go to Parameters tab here, I click plus, type will be floating point number, and I will call it move X. I add one more, float, and I call it move Y. Here I select move X and move Y as parameters. If move X is 0 and move Y is -1, character is facing down. 0 plus 1 is up, -1 horizontal and 0 vertical is left, and +1, 0 is right. I get 9 here, not a number, so I put 0 inside. Okay, so Animator tab, player object selected here to see a preview, and we are inside the idle state. That gives me this image. You can see if I move X between -1, 0 and +1, the character is turning left and right. If I use move Y slider, character is facing up and down. That works. These are variables, parameters. I need to go to my code editor inside player controller CS file, and I need to attach some values to move X and move Y so that our idle blend tree can swap between 4 idle states as variables represented here as move X and move Y change values. I only want to switch directional animations if the player is actually moving. If RB, rigid body velocity, is not vector2 0 0, because if velocity is 0 0, player is standing still and there is no need for this code to run. I take animator component on the player and I call built-in setFloat method. Inside, I pass it moveX parameter we created inside the animator in Unity, and I want to set it to the current input.x value. This will work, but if you press multiple keys, player will sometimes face in a different direction than where it is actually moving, so it's better to use rb.velocity.x. If player is moving, set moveX to the horizontal velocity of rigid body component. We will also set move y parameter to the vertical velocity of rigid body. I save changes and wait for Unity to compile. I get an error that says animator variable I used on line 29 or 30 does not exist in the current context. If you remember from before, we used our script to access rigid body component, this one, from inside player controller script. I minimize these. Now I'm basically trying to do the same thing to access the animator component from inside player controller script so that I can manipulate its move x and move y parameters. Okay, so we want to access animator from the script. We already know how to do that, same as we did when we accessed rigid body component. I declare a private variable, type is animator, name of the variable is animator. Inside start method, I take that custom animate variable and I point it towards the animator component on player object, like this. Now I can use animator variable inside fixed update and it will work. If player is moving, take animator component and set its move x and move y parameters equal to the current horizontal and vertical velocity. I save changes. Here in Assets Animations, if my player controller is open, I can see this in Animator window, and we know that those move x and move y parameters determine which one of the branches in idle blend tree will be selected and which idle animation will be played. Because of our script we just wrote, these animation branches now depend on player's current velocity. I have a typo somewhere in my code, let's see. Animator here needs to start with a capital A. Save changes. I'm on the Game tab and I press play. This looks good. I can double-click this small game label to make it full screen. We are playing idle animation in the direction of player movement. Perfect. This is a great use case for blend tree in Unity. I can exit full screen mode by double-clicking Game tab label again or by exiting the play mode. Now let's create walk-in animations. We already know how to do that. I give myself more space here. I have player game object selected and I open animation window. If you don't see it, you can go to Window, Animation, Animation. I click on this drop down and create new clip. Make sure you are inside Assets Animations here, and I create new animation sequence called Walk Down. Save. I go to Assets, Art, Player. I expand Player Sprite Sheet. In case of my pale green orc, my walk down animation sequence starts with frame. This first frame is idle, so from player 79. I hold Shift key down and I click on player 86. It will select all the frames in between. I make sure walk down is selected here and I drag and drop these 8 frames. I play it. It's too fast. Sample rate could be something like 7, I guess. If you don't see sample rate, click on these 3 dots and show sample rate. I play the animation. This looks good. Again, create new clip. Walk up. 60 is idle, so player 61. I hold Shift down and I click on player 68. I drag all frames here. Too fast. Samples set to 7. Good. Create new clip. Walk left. From player 70 to player 77. Your sprite sheet might be different. You need to test the animations here and see if they look all right. Samples 7, and we have a nice continuous walk left animation sequence. Finally, create new clip. Walk right. Player 88 to player 95. I drag it here. Sample rate is 7. Play to test. Looks good. I go inside Animator tab up here. If you closed it, you can go to Assets Animations. Here you can see the 4 new walk animations we created. You can double-click Player Controller to open the Animator window. You can also go to Window, Animation, Animator to open this window. Okay, so Player Object selected here, Animator window here, and I go back to the base layer. Unity auto-generated a state for each animation sequence. We want to use a blend tree, so I delete all these 4 walk-in states. Right-click, create state from new blend tree, Inspector tab, and I rename it to walk. Move it a little bit, and I double-click the walk state. I'm inside base layer walk right now. I select this blend tree, and inside inspector I rename it to walk as well. Blend type is 2D simple directional. We have these 2 float parameters we called moveX and moveY. We use them for idle, and we will use them for walk. This will basically be the same thing we did for idle. I click on the plus here, add motion field. I add 4 of them. I click here. I select walk down animation sequence we created before with 8 animation frames. Walk up here. Walk left here. Walk right here. Walk down is 0 horizontal, -1 vertical. Walk up is 0, 1. Walk left is -1, 0. Walk right is +1 and 0. I type 0 here inside moveY field to fix this. Okay, and if I slide these, player moves left and right while walking. MoveY parameter moves up and down. I'm inside my animator window and I go to Parameters tab. Plus to create a new parameter, and this time it will be a boolean, which is a variable type that can be true or false. I will call it moving. We will use it to switch between idle and walk states. I'm back up inside the base layer. I right-click idle and select Make Transition. I drag the transition arrow from idle to walk. Now I can click on the arrow. With the transition selected inside Inspector window, I go to Conditions and I click plus to add to the list. If moving, which is a boolean, is true, we transition from idle to walk. This is pixel art, so I want the transition to be instant. I untick has exit time. I expand settings here and transition duration will be 0. Back here, I right-click on walk state, make transition, and I drag the transition arrow to idle. With this new transition from walk to idle state selected, inside the inspector, I untick has exit time. Transition duration will be 0. I scroll down to conditions, plus to add to the list, we want to transition from walk back to idle if moving parameter is false. You can ignore this error, not sure why it didn't disappear at this point. I go back to my code editor, inside player controller CS file. Here inside fixed update, we check if velocity of rigid body component attached to the player is not 0, 0, which means that the player is moving. In that case, we take animator component and we set boolean we called moving to true. That's this parameter here that controls transitions between idle and walk states. Else, if velocity of player rigid body is 0, 0, it means that the player is not moving. So in here I can take animator again, and I set boolean moving to false. I told you writing scripts in Unity is easy. I will link all the scripts in this project in the description below separately, so you can quickly check it if you made a typo somewhere and you can't find it. Because we are using Unity's built-in features, we need only very little code here to achieve what we need. I save changes and I wait for Unity to update. This error should disappear when I press play. I'm in idle, I walk, and we are playing the walking animation. When I stop, we play the idle animation. You can double-click this small label to make the window full screen. Let's try all 4 directions to make sure. So now you know how to create a 4-directional animated movement in a top-down RPG in Unity. You can use this for so many things. Nice work! Because of the fact that we are moving the player using its rigid body velocity, we can now easily use Unity's built-in collision detection system. For example, let's create a layer of collision tiles in the game world. I right-click on my grid object, 2D object, tile map, rectangular. I will call it collision objects. I go to Layers, Edit Layers. I'm inside Sort in Layers drop-down and I click plus to add more. Layer 4 will be called Collisions. And I put it behind Player, but after background here. Collision Objects tile map selected here, and inside Inspector, I set Sort in Layer to Collisions. It's good to save as often as possible. When I see an asterisk here, I press Ctrl S to save my changes. We have made a lot of changes to the layout, so I can go to Window Layouts and Default so that we all see the same thing. I open my sample scene. I go to Window 2D Tile Palette and I drag it anywhere. I like to have it here on the right because I never need Tile Palette and Inspector at the same time side by side. We will be drawing game world, so let's give ourselves more space. We have sunny cave walls and dark cave walls in our palette. We will use both. Here I select which tile map object I want to draw on. I want to draw on collision objects now. With brush tool selected, I can highlight this entire sunny cave entrance and I can place it somewhere around here. This is where my player lives. Let's see how these tiles connect together. I think this edge will work if I put it here. Yes, and this edge on the other side. To draw on collision objects tile map, it's not necessary to have it selected here as long as I have it selected here. But if I do select it here as well, it will be highlighted so I can easily see what I have on that layer. I select collision objects here and I go to Inspector tab, Add Component, and I type Tile. I'm looking for Tile Map Collider 2D. I will add another component, this time Composite Collider 2D. This collider merges the shapes and it's better for performance. You'll notice that it also automatically added Rigid Body 2D component, which means that when I press play, something funny will happen. It will fall. I exit the play mode, Collision Objects Tile Map selected here, Inspector tab, and I find Rigid Body 2D component. I set body type to static. Because of the fact that we chose to move our player using rigid body velocity technique rather than manipulate its transforms, Unity's physics system will already detect collision between player and collision objects tile map. All we have to do to enable these collisions is to select player object here. In Inspector tab, I click Add Component, and we need to add one of multiple collider types that Unity offers. To keep it simple, I will add Box Collider 2D. And that's it. No need to write any more custom code to implement collisions. I press play. By default, objects will rotate when they collide, which can result in some funny scenarios, but this is fully expected. I exit the play mode. Player object selected here. I find its rigid body 2D component, and here in constraints I freeze rotation around z-axis. Notice that this entire big box is the player collider, so it will detect collisions when the player is still quite far away from the cave walls. I exit play mode, player object selected, Inspector, and Box Collider 2D component here. We can click this button to edit collider geometry. I click it, and for Box Collider, it gives me these 4 small anchor points. For 2D top-down RPG, we want the collision area to be just around player's feet. If you make it too small, the shadow can clip through some objects, so I will try to match the size of the collider to the size of the shadow at player's feet. We can try to edit this later if needed. Now I can get much closer to the cave wall. This is better. Implementing collisions is very easy in Unity. What if I want to have some kind of an object on the ground that the player can walk around? I go to Art, World, and here we have this other image we imported in the beginning that was part of the Cave World package. It's called Decorative. If I expand it, I see it's made from a single frame only. I go to Inspector, as always, and I set pixels per unit to 32. Sprite mode is multiple. This image has multiple frames. It's pixel art, so filter mode, point no filter, and compression set to none. I click Apply. I open Sprite Editor. I want to slice this into frames. This is not a tile map, so it's not as clear-cut what we should do here. We have multiple options. I can, for example, still slice this by 32 to 32, and each object will be made out of multiple tiles. This is useful for what I'm trying to do next. I click Slice and Apply. Unity discarded the empty frames and auto-generated names and coordinates for frames that have some pixel data. I close Sprite Editor and I go to Tile Palette. Here I click inside this drop-down and create new palette. I name it, for example, Objects, and I click Create. I put it inside Assets, Art, World, Tiles, and I select Folder. So here, Tile Palette window with Objects palette selected. Down here I have my images. Now I can drag and drop this in here to create tiles for my new palette. Again, I will be prompted to specify where I want to save this, so I stay in Tiles folder and I press Select Folder. With the standard brush, I can highlight this area of 3×3 and I can place it in the game world. Notice that if I select background tile map, it will delete the ground textures. We don't want that. We want to place this on collision objects tile map, but I want the player to collide only with the bottom part, and I want the player to be able to walk behind the top of this rock to kind of create an illusion of depth in a 2D space. I go to Hierarchy and I right-click Grid. 2D object, tile map, rectangular. I will call it Foreground Objects. Collision Objects Tile Map game object has Tile Map Collider component. Player will collide with these tiles. I want foreground objects to have no collision and to be drawn in front of the player character. So here in Tile Palette, with Collision Object selected, I want only these bottom 6 tiles to trigger collisions. I place them here. I click on Foreground Objects and I get the highlight. I can see that Unity will also automatically select foreground objects here, which is needed. Nice. I want these 3 tiles on top in front of the player and not to trigger any collisions. Foreground object selected here, inspector, and sorting layer will be foreground. Now we can see them. If I go to layers and edit layers, we can see that foreground should be drawn in front of everything else. Playtest. I double click here to make it larger. The bottom of this rock is solid and player can't walk through it. But if I walk around, we are walking behind the top spikes. Very nice. You can see that the player is drawn in front when we walk down here and behind when we walk up here. That's perfect. This is a quick and easy way to create an illusion of depth in your top-down 2D game. You can create some nice complex game worlds with this simple technique. I hope you are getting some value so far. We have a small single screen game. How do we make the game area much larger, and how do we make the camera follow the player? Join me in the next lesson to find out. In the first episode, we designed and implemented a keyboard-controlled player character, and we learned how easy it is to add physics to the game if you understand the fundamental rules of 2D movement in Unity. Let's expand the game map, make it larger and more diverse, and implement a cinematic, pixel-perfect camera to follow the player around. With background tile map game object selected here and tile palette window here, I select World Tile Palette. I will continue using these 2 patches of tiles. Grass surrounded by dirt and dirt surrounded by grass. This tile map offers much more, and we could create more scenes here. We only have 1 sample scene so far. We could set this cave entrance as a collider with an event that will transition us to another game scene, for example. And in there we could use another set of tiles to make a distinct level. So many possibilities here. For now, I will just take the 9 grass tiles and I will roughly outline some grass patches in the world. Make sure background is selected here. We want to draw on the background layer. If you also select it here, it will be highlighted like this. Now I will fill this space with a block of 9 dirt tiles. Doing it this way would give us a repeating pattern, so I will use the random brush we created earlier. You don't have to follow what I'm doing here. Use your own world design ideas. The only goal here is to make the background layer larger than the area that the game camera can see so that we can walk around with the player and have the game camera follow us. The process of creating a world using a tile map can be automated by using, for example, something called rule tiles, where the edges of the grass would be automatically filled by Unity based on the shape of the grass patch, based on some rules that we predefine. Then I can make large areas and multiple levels quickly. I select Collision Objects layer here to tell Unity which tile map object we want to draw on. If I also select it here, we will get everything drawn on that layer highlighted. So far, only these two blocks create collisions. I could choose a cave block like this, draw it on the Collision Objects layer, and it will automatically create an impassable barrier for the player. I still have my random brush selected here, so I'm actually drawing dirt tiles. I need to go back to default brush. Now, collision objects selected in these two places still. I can design my cave walls. I delete this one. Big block of dark tiles. Now some bottom tiles here. I need to get used to this tile set to understand how the cave blocks connect. I keep going left. Side piece here, like this. Now I can do the other side. These four, and I go all the way to the right, and a corner piece here. I test it. To actually walk there, we need a game camera to follow the player. In Unity, we can simply take the main camera game object here, and I drag it over the player, like this. I make the preview larger. Okay, so making the camera follow the player takes only one click in Unity. Maybe some of you didn't expect it would be this easy. Now we can walk down and explore the bottom edge we just created. Player is colliding with the cave tiles. Perfect. Notice how the shadow at player's feet doesn't even touch the cave walls. I would prefer the collision area to be a little bit down to enforce the perspective. I would actually prefer if the player could walk maybe half of its body behind these bottom cave tiles. I highlight my collision objects here. I want to move this entire cave block from collision objects layer to foreground objects layer so that it doesn't trigger collisions and it's drawn in front of the player. While I have collision objects selected here, I can use this tool called Pick or Marquee Select New Brush. This allows me to click and drag my mouse over all these tiles, and now I can draw this identical block again wherever I need it. I want it drawn on foreground objects layer in exactly the same position. So now I have this identical block of tiles drawn on two layers on top of each other. I want to delete it from the collision layer. I select collision objects here. I increase the brush area like this, and I select the eraser tool. I completely delete this from the collision objects layer. Now I pick, let's say, one dark tile. Collision objects selected here, and I want to define the collision area using this technique. I just draw this black tile behind, under the cave walls, wherever I want to create a barrier for the player. Notice I'm going one tile down, allowing the player to walk behind the top part of the cave. I playtest it. I walk down. Yes, this is exactly what I want. To create an illusion, we are looking at the game world top down, but slightly from an angle. Perfect. The top wall will be done differently. I will actually draw that on collision objects layer because this part can be drawn behind the player character. Let's also do the right side. I made this much more irregular. So I have to work out how these cave tiles connect in a continuous way. A little bit further up, maybe even more. This connects here, maybe this piece here. Now I go back down. Corner connector, not this one. I guess another corner here and here. Yes, so this is the top wall that I want to be drawn behind the player to further enforce the view from top down under an angle. I select the background layer here, random brush, and I fill the gaps between the ground texture and walls. Now I want to do the side walls, which will also be slightly different. I select a single black tile and I go back to the default brush. Collision objects layer selected here and here. I define the left collision wall like this, all the way down. Maybe I can fill these pieces here as well. I define the right collision wall here like this, with a single layer of black tiles. Perfect. You can see we locked the player in from all sides. It cannot leave the game area anymore. In play mode, I can better see where the connections need to be fixed. I exit the play mode. I use this corner piece block here. Background layer, random brush, and I fill the ground textures here. Back to the default brush. This area needs some attention. I will actually move the corner transition one piece to the right. Black tiles here. Background tile map selected here. I take a block of 6 dark tiles from this area and I will create a dark left edge. Actually, maybe I want to cover a large area with just black tiles at first as a base. Black tile selected here. Filled box tool here. I want to go far enough so that when the player walks all the way to the edge of the cave wall, they cannot see any unpainted area. Background layer selected here to get a highlight. I want some ground dirt tiles here. Dark tiles here. Dirt tile. Dark tile. I will fill this one on the background layer. So whatever is highlighted now is the background layer. Collision objects layer, things that player will collide with, and foreground objects layer, things that are drawn in front of the player. With foreground objects selected here and here, I use Erase tool to delete these. I select Objects Tile Map. I take this dark spike. I would like that to be drawn here, but if I put it on the foreground layer, you will see it deletes the cave foreground tiles. We will need a second foreground layer to achieve this. I right-click on the grid, 2D object, tile map, rectangular. I will call it foreground 2, inspector tab, sort in layer will be foreground, and order in layer will be 1 on top of the other foreground layer. Tile palette, and I select foreground 2. Now I can place my spikes down here. I will also put some on the sides here, up top, and some on the left. I can use this smaller piece in a few places, few more here. I play and I walk down. Yes, this is exactly what I want. Notice they are drawn in front of the player. Let's do the side walls. I select World Tile Palette. I want to draw on foreground objects layer. This tile map has these overhanging side walls and I want player to walk kind of under the protruding stones. Okay, let's plan this transition. I select collision objects here. This piece needs to be on the collision layer. These are the collision tiles, yes. Now I can go to foreground objects tile map here and I select this block. Notice that we have some overhanging rocks that will be drawn on top of the player in front of it. I just tile this left edge all the way down. If you want to build your own tile set, you can skip this part. You can just jump to the next chapter. I will be polishing my level for a little bit longer. Playtest and I walk to the left wall. Perfect. This is exactly what I want. Notice that the cave wall tile map has these barely visible pieces, rocks that are partially hidden in shadow. I can just grab them and place them randomly. I can also grab this bigger side block to draw it in a few places here. This bit on the top side. Maybe this piece here to make the cave go gradually into the darkness. Now I want the right side cave wall. I go all the way down, some corner pieces here. For this bit, I will use this block. Maybe this one here. And then we go down here. I patch a few more tiles here, shadow pieces all the way down. Okay, I will play, make it larger, and I will walk along the walls. One problem here, this will need fixing. How does this transition from sunny to dark cave wall looks? I'm noticing and remembering some small details, and I will fix them when I exit play mode. I also need to make sure we can't see this edge, so the black background tiles will need to go deeper. I exit the play mode and I will do some small fixes to make sure the tiles connect. I'm doing this level manually because this is a class for complete beginners. If you need to create many levels, Unity offers tools to automate this process. You can just draw one rough shape and it will automatically decide the right pieces for you. It's called rule tiles. I will explore that deeper in another class. I kinda enjoy painting the level tile by tile myself, but some of you just might want to get things done quicker. Rule tiles take a while to set up, but once you have the logic in place, you can create many different game scenes, levels, and map layouts very fast. This is the first project I'm using this beautiful complex cave tile map for, so I'm not fully familiar with it. If you build a big game, you will know your art assets and you will know your tile sets well, trust me. I add a few more spikes. I like how we have 3 different sizes. It creates a lot of detail in what would otherwise be boring black cave walls. The left collision wall made from black tiles is slightly visible here. So I exit play mode, collision objects selected here, and instead I will paint this left collision wall with dirt tiles. Foreground objects, black tile, and I patch this. I do the same thing for the right side of the map. Now I have the patch of grass here surrounded by dirt. I need to do the transition around it, like we did in the first part of this video. This process can also be automated using rule tiles. I will just go all around the grass patch and I will create the edges to make it look nice. I think I'm going to time-lapse this part because we already explained how these pieces fit together, and I'm sure you want to create your own layout that will be different to mine. I will then place some ground clutter objects like patches of moss and some stones. When I'm happy with my level, I enter play mode and I will walk around to spot any potential issues, just making sure all my cave walls and all the grass patches connect seamlessly. Also making sure we can't see outside the painted area, which we can still see here on the left. So background tile map here, simple black tile, and filled box paintbrush. I will just go much deeper to make sure we cover far enough. I select collision objects here. We also have some underground lake tiles. These can also be organized into any shape. I will simply use a rectangular shape here, but feel free to build some complex lakes and rivers, and we even have bridges here. Where do I want my lake? Maybe in this corner. This is where my player goes to fish and swim. I can also go to objects. These 4 bottom tiles on the collision objects layer. This will be on the foreground objects layer so that the player can walk behind the top spike. Yes, this is fine. Maybe a capsule collider instead of a box collider on the player could work better here to slide along the edges of obstacles. I go check out my fishing lake. It's on the collision layer, so I can't jump inside. Okay, I adjust my windows. Let's have a look at the game camera. Player object selected here. I center the position inside the transform component. Then I select main camera and I center it as well here. You can see some imperfections between tiles when we walk. They will disappear if you select the correct aspect ratio. For example, Full HD here will fix that. With pixel art, we can also sometimes experience some issues with camera motion. I can fix that by selecting main camera, add component, and pixel perfect camera. Let's see. I want reference resolution to be some values divisible by 32. So for example, 320 times 192. And pixels per unit will be 32 here. You can see some imperfections between tiles. If I set this to Full HD, it should fix that. That's better. We can add more advanced camera motion as well. I go to Window and Package Manager. These are packages installed in our project. I go to Unity Registry if I want to find more packages to install. I search for Cinemachine. I find it here and I click Install. I add it here, Cinemachine, Virtual Camera. You can see it disabled the main game camera and it took over its role. I select Virtual Camera here and I want to drag player object into the Follow field. There is a bit of an animation now to the camera motion. Camera feels a bit heavier. I think this is pretty good. With the new virtual camera selected, I go down here to extensions and I add extension called Cinemachine Pixel Perfect. Now I can change the value here in ortho size to set the distance of the camera. We have a game world for the player to discover and explore, and we have a pixel perfect animated virtual camera following us around. I can go here to Tile Palette window with Objects palette open, and we have some crystals and mushrooms. These could be, for example, collectible items in the game. For now, I will just select Collision Objects tile map here, and maybe I can place some of these crystals as solid obstacles in the world. This corner around the lake is wet, so maybe some of these mushrooms grow here. And in this corner, partially in the sun, the dirt crystallizes into these differently colored shapes. The tile palette we are using has a lot of things we can use for many different gameplay features. We have some solid ground objects, crystals and mushrooms that the player will collide with. We learned a lot today. I go to Window, Layout, Default to reset my Unity panels so that we all see the same thing. Also, don't forget to save your changes. In the next part, we will learn how to add button elements and how to write a very simple script to quit the game after clicking a button. And since we're talking about clicking buttons, you can click the like if you're getting some value. We are building a 2D top-down pixel art RPG in Unity. Let's create a quit game button. You can use the same step-by-step approach for any game. It doesn't have to be this specific project I have here. Unity uses a game object-based UI system. Let's cover how it's done in 3 steps. Creating a canvas, positioning elements, and defining user interactions. Whenever I reset my layout to default, I have to set the aspect ratio again here in this drop-down. I go to Window, 2D Tile Palette. I inspected my 4 tile maps in detail and I will do one final pass, polishing the edges. There is a GitHub repo with the final Unity project from the end of this episode, as well as a playable HTML version of the game in a state the game will be at the end of this episode. I wanted to show you how to create a very basic UI element, a quit game button, and how to attach a simple C# script to it to quit the game when we click it. I go to Hierarchy here, right-click UI button. You can see it automatically created a canvas object with a child button object inside. If I select canvas here and press F on my keyboard to focus it, you will notice that canvas is much larger than my game world. I select grid and I press F to focus. You can see the significant size difference. If I inspect the button, it has a child object called text. TMP is Text Mesh Pro, Unity's easy-to-use system for high-quality text that allows us to format the text and change its appearance. With Button Game Object selected, and here, inside the Inspector tab, I can change the color. I can also use an eyedropper tool here to use one of the colors that exist in the game scene. If I select the text element, I can see the text should read button, but I don't see anything here. I change the text to quit. This will be a quit game button. Unity cannot render text unless I import Essential Text Mesh Pro resources into this project. Now the text is finally visible, barely visible. I will also import examples and extras. With text object selected here, I can change the color of the text here. I can also use the eyedropper tool and choose text color from the game world. You can change the colors of the button here: normal color, highlighted color, pressed color, and so on. Canvas is still large, and playable game area is tiny in comparison. If I enter play mode, you can see that Canvas will actually overlay itself to fill the game view, so the quit button is here, in the bottom left corner. With Canvas object selected here, I go to Canvas component and set render mode to screen space camera. And I drag the main camera object into the render camera field here. Now Canvas adjusts itself to the main camera size. I can't see the button, so with Canvas selected, I set sorting layer to foreground here. I can resize my button in its rectangular transform component. I can select Move tool and drag this blue square around to position it somewhere else. Playtest. Now the button is behind the foreground tile map layer. Foreground objects tile map is on the foreground sorting layer, order in layer 0. Foreground 2 is on the same sorting layer, but order in layer is 1, so on top of it. Canvas element is also on the same foreground sorting layer now, and to make sure it's always in front of everything and always fully visible, I set order in layer to 10. Playtest, and if I walk around, you can see the button is always on top. It changes color when I click it. With button object selected, inside the Inspector tab, we can change normal color of the button here. You can set these to whatever you want. Here is a highlight color and pressed color. I will make them into shades of blue, I guess. And let's make the text white. Bold, size 28. I can move the button to a different corner. This will work if we make a build for the game for the desktop computer, but button positioned like this will not work if we export it as a responsive web game. There is much more to the layouts, but let's keep it simple for now. We will build this as a desktop application for Windows and Mac computers. It will be a normal, full-screen computer program, so I want to add a button we can click to exit the game. In Unity, it takes only one line of code to implement that functionality. In Assets, Scripts, I right-click, Create C# script. I will call it Quit. I wait for Unity to process this, and I click this script file to open it in my default code editor. As always, Unity auto-generates this class. It extends monobehavior and has some default auto-generated methods. I will delete all of this because what we need is very simple this time. I create a method, public void quit game, and inside I just say application.quit, like this. Careful about capital and lowercase letters. Notice I'm setting this as public here. I save changes and I wait for Unity to deal with it. Here I can see my script has updated. The easiest thing I can do here is to right-click, create empty, and rename this game object to handle quit game. With handle quit game object selected, I go to Inspector, add component, and I will add this new quit script we just wrote. I select my button here. I scroll down inside Inspector, and here we have this button component, and inside we have a list of on-click events. Plus button here to add one, and I drag handle quit game object here. I select the quit script and the public quit game method we just wrote. So when we click the quit button, take handle quit game object and run its public quit game method. That's all. If I click the button in play mode, nothing will happen. But when you turn this into desktop computer application, clicking the button will quit the app. To export my game as a native Windows desktop app, I go to File, Build Settings. In Unity 6, this might say Build Profiles. In here, I select which platform I want to export my game for. If this is the first time you are creating a build for this platform, you will have to click Install with Unity Hub to download that particular module. As you can see, you can export your game for Android and iOS. If you are doing that, make sure your game has suitable mobile phone controls. We can also turn this into a web game. It was called WebGL in all the versions of Unity. In Unity 6, this option will just say web. Web version will give you a small local folder, and you can upload that somewhere online, on your own server or maybe itch.io, to allow people to play your game in a web browser. I put the web version of this project on Unity Play. It's linked in the video description if you want to give it a try and see how that works. If you are exporting for web and you have some UI elements, you should also click on Canvas and in Canvas Scaler component, set UI Scale Mode to scale with screen size. Give it some reference resolution and reference pixels per unit. This will make sure your UI works in web view as well. I will export this for Windows, Mac and Linux. I click Build or Build and Run. I create a local folder for Unity to create all necessary build files, and I select Folder. This process can take a while, depending on the size of your game and on the processing power of your computer. When it's done, I find that local folder and I click this .exe file. This will open my game as a full-screen desktop app. Well done for finishing this basic course. Now that you know all of this, it's time to make some full games.